Welcome back. We're still in week 5, module 10, and we're going to talk about radiology information systems. Radiology information systems have to do with the images. So if you've ever gotten an X-ray, an MRI, any type of image, that's considered a radiology information system. And these have come a long way in the past 10 years. For any of you that have had a patient encounter involving an image, 10 years ago, you would have to run around town and actually pick up films and transport them from one provider to another provider. These films had to be read from those films, and then you had to return them back to where you originally got them from. Sometimes there would even be a cost for a patient. So things have really changed in terms of radiology information systems. We have 3 learning objectives for this module. 1, define radiology information system. 2, describe picture archiving and communication systems, otherwise known as PACS, P-A-C-S. Digital imaging and communications in medicine, also known as DICOM, D-I-C-M, and artificial intelligence for radiology information systems. And we'll describe use cases for RIS. So let's start with what is new in RIS. So machine learning and cognitive computing are being applied to radiology to increase productivity and ultimately aid in diagnosis. Diagnostic imaging interpretation, AI-enabled diagnostic imaging interpretation uses deep learning techniques and categorization technology on very large data sets of medical images in order to create algorithms that allow for faster and more accurate reading of X-ray studies, MRI exams, and computerized tomography, or otherwise known as CT scans. By aiding image diagnosis, the incidence of missed or inaccurate diagnoses should decrease, and these solutions will also help alleviate the projected severe and growing shortage of imaging specialists and also help with burnout and increased morale. And when it comes to these deep learning techniques and categorization technology, these are things that are covered in the HIM 5129 analytics course. Many of the tools such as decision trees are used in AI, machine learning, and deep learning techniques. So now let's take a step back and define radiology information systems. This is a networked software system for managing medical imagery and associated data. And recently we've also started using what we call a VNA. A vendor neutral archive is a technology that stores medical images in a standard format and interface, making them accessible to healthcare professionals regardless of what proprietary system created the images. So, historically, if somebody had one type of PACS system, it wasn't always in the same format, and that image could not be shared with other systems. Let's talk about describing picture archiving and communication systems, digital imaging and communications in medicine, and artificial intelligence for RIS. Well, PACS is a medical imaging technology used primarily in healthcare organizations to securely store and digitally transmit electronic images and clinically relevant reports. DICOM is the standard for the communication and management of medical imaging information and related data. And so many times, prior to having portals and easier ways for patients to access and view their own images, maybe about 5 to 10 years ago, if you received a CD, a compact disc, with your images from your provider, you could go online on the internet and download a free utility to be able to take a look at DICOM images and look at those images yourself. Artificial intelligence in medicine may be characterized as the scientific discipline pertaining to research studies, projects, and applications that aim at supporting decision-based medical tasks through knowledge and/or data-intensive computer-based solutions that ultimately support and improve the performance. And specifically, this would be for radiology information systems. Although artificial intelligence can be for many other medical procedures and functions. For our purposes for this module, we're talking specifically for radiology. And if we describe use cases for RIS, an RIS is especially useful for tracking radiology imaging orders and billing information, and is often used in conjunction with PACS and VNAs to manage image archives, record keeping, and billing. So in summary, these are more forward-looking items to be aware of. The vendor-neutral archive originated as a technology response to the prodigious storage requirements of picture archiving and communication systems, and the onerous cost and complexity of PACS to PACS migrations. The VNA value proposition has evolved to include standards-based image access and sharing, EHR and workflow integration, universal image viewing, and enterprise worklist capabilities. The VNA has been promoted for its standard-based interoperability and its support for non-digital imaging and communications in medicine data, mobile applications, analytics, and artificial intelligence. The VNA will enable healthcare providers to manage all unstructured data resulting from patient events and care activity and make it available to all systems and stakeholders. While the VNA in and of itself is not a comprehensive enterprise image strategy, it will come to be a considered key component. And this is as of the end of 2018, and many healthcare providers are already in the process of putting in VNAs. So here's some recommendations for RIS when we look to the future. Healthcare provider CIOs leveraging EHRs, telemedicine, and digital care delivery IT should select a VNA that is agnostic to your existing PACS and storage infrastructure. It should really be a vendor that is not tied into just one particular type or brand of PACS system. Select a VNA that will image enable your electronic medical record, provide for universal viewing and mobile app support, and offer collaborative capabilities such as workflow integration and enterprise worklist processing, and artificial intelligence enhanced analytics and decision support. Deploy a VNA to decrease the dependence on departmental PACS and increase the control and ownership over medical imaging data and other patient care related unstructured content. This is really big because historically there have been departments in hospitals where it's one small team managing the PACS system and they don't like to share the data. Make the VNA the underpinning of your enterprise imaging strategy and information sharing architecture by crafting a strategy that takes into account all of the medical imaging ologies and oscopies surrounding patient care and satisfies real-time healthcare system transformational requirements. At this point, you can proceed to week 6, module 11, after completing the week 5 Canvas assignments. Thank you.